Hey everybody, this is Baylor, and in today's exciting episode, I'm going to show you how to solve the Queen's Attack 2 problem in such a way that even if you were just totally confused by this problem like I was, I have a system that I'm going to use to show you so that I guarantee you by the end of this video, you will understand the problem 100% and you'll be able to solve it without any doubts. So let's just jump straight into it. This problem is pretty straightforward, and we have some things that are kind of giving us the edge. They're helping us. And the big one here is that we are standing on an n by n board. It means that it's always a square. That's huge. And from there, all we're trying to do is count how many squares does the queen attack in all 8 directions. Okay, so it seems... Is that right? That's 8? Yeah, 1, 2, 3, 4. Yeah, that's 8. You know what? I might have said the wrong thing. So I had to count. And that is important to know because I'm not a genius. I'm just a regular guy. And I'm going to try to help you understand it without having to be a genius. And so if you can understand it after I teach it to you, you're already doing really good. Okay. So yeah, this is where we stand. We know that we're on a square board. We're trying to count how many squares we attack with a queen. And the other thing we know is that we get a variable number of obstacles on the board. We don't know how many there are. And I think there's even rules on here that say like they may be on the same square. They're going to be all over the map. You have no idea how many there are, anything like that. And this n can be huge. So that we need something fast. We can't just sit there and try to build this out like what I did when I started is I tried to build this out in a one-dimensional array. I can tell you right now, don't try it. It was fun and it was actually easier to work with than a two-dimensional array, but it was slow and it just didn't work. And so I would not recommend doing it that way. So I'm going to show you how to do it an easier way. So what I have here is this little tool that I threw together, and I built this tool because I thought, you know what, this is too confusing. I cannot keep trying to change these variables and draw this out in text. I thought I want a tool where I can drag the queen around. I want to be able to look actually with my eyes and figure out like how far is it attacking all these directions and stuff. And I just pieced it together and suddenly I had this thing and I thought, wow, I understand this problem. And I'm hoping it'll teach you. So let's just kind of run through it. This tool, I can turn on and off directions so that we can actually look at them. I can isolate to a single direction so that we can just focus on that. And then I can click on the squares to highlight them. And then finally, I can drag a pawn onto the board. And that allows us to limit where we can actually play with this with actual obstacles. And then the last great thing is that I have to refresh the whole page to get rid of the pawn. Okay, so this demo is only demo mode. It is not ready for production. Okay, so let's focus in on our simplest case. I think the simplest case is how many squares do we attack to the top of the queen? So, I mean, we can look to here. If I move way over here, I've got 3. And if I come down here, if I can drag it right, now I have 5. Okay, so we can see with our eyes what we're doing. We can see how many we've got. So what we need to look at is, well, how do we know that there's 3 here? Well, when we think about this, we know that the queen is on the 4th square, like 1, 2, 3, 4. So we can look at that. If we say, like, what's my queen dot y? You can see, well, my queen y is 4. And that's right, we can see that, I put it here. And so what I could also do is say, well, if I take away 1, right, if I don't count the square that I'm on, that's 3. And that's exactly right. We say queen dot y minus 1 is 3. We solved it. We know, if I type in this variable top, we know that we have 3 squares to the top of the queen that we can attack. Boom. That was actually really easy. I think it's going to be the same way on the left, right? We know that our queen is 1, 2, 3, 4, 5 squares to the right. If we look at that, queen dot x, it's 5. We say queen dot x minus 1 is 4. So we are not counting the square we're on. We've got 4. Boom. So we now know how many squares we attack to the left of the queen, and that's 4. Okay, so already this problem is breaking it down because, like, if I turn on top here, That's 6. We can check that. Top plus left. 6. Boom. We already know that at a minimum, we are attacking 6 squares with this queen. Okay, so let's focus in only on the right. Now this one's tricky, because if we look at our queen.x, we only have 2. We are not... How do we reverse this to go this direction? Well, what do we know? Well, we know that our queen's attacking all the way to the end of the board. This board, like the number of squares here, is 6. And that's also the size of my board, right? I have this board size of 6. So if I reset this, so let's try that. We look at board size. I have this variable, board size, or board size is 6. I say board size minus queen.x, that gives me 4. Well, sure enough, that's actually the number of squares we attack to the right of the queen. Okay, so if we look at that variable, right, we know we got 4 squares to the right of the queen. We're attacking 4 squares. I bet it does the same thing on the bottom, too. We look at our queen.y, it's 3. We take our board size minus queen.y, and it's 3. And there you go. We got 3 squares to the bottom. And so if we want to know how many squares we're attacking all 4 directions, well, right now we can see this is 10. We got 3, 2, 2, 3. That's 5, 10, right? 5, 5, 10, blah, blah, blah. However you want to count it, we can say top plus right plus left plus bottom, and that's 10. So we know right away how to count all the squares in orthogonal directions of our queen. And we're doing it strictly by using the size of the board with the position of our queen. Okay, so we have got this down. Okay, so now we're ready for the next step, which, you know what, it looks kind of tricky, but it's really not. That is, how do we count how many squares we are attacking on our diagonal? Well, what I'm going to do is just turn off these other two, because let's focus on kind of what I'd say is the easiest one, going to the top left. And if I go here, I call this the simplest case. And you say, oh, no, Baylor, it has to be here, right? But no, it's not here. I guarantee you. You know why? Because here I can actually see with my own eyes, I've got 1 square that I'm attacking. Okay, so we know if we're here, we have 1 square. And what is here? Well, we know that our queen.x is 1. I'm sorry. My queen.x is 2, and my queen.y is also 2, right? You see what's going on here? Baylor's counting 0 indexes. I think it was Jeff Atwood that said something like, all programming problems have off by 1 errors. So does Baylor. Baylor doesn't necessarily have to be a program to have off by 1 errors, but he's got them. And I blame computers for that. Yes. So we'll just move along and ignore my inability to remember that this is a 1 index system. So we know that our queen is at 2 and 2, okay? And that doesn't really help us. But what does help us is that we have queen... You know what? This is like a horrible way to think about it. Let me start over on this, okay? We've got 1 square to the top, okay? To the top left. If I move the queen here, I still only have 1 square. 1 square. Where else do I only see 1 square? I don't know. Let's think about this. If I move down, now I have 2 squares. Where else do I see 2 squares? I don't know. Let's move down again. Well, I still only have 2 squares. Where else do I have 2 squares? You see what I'm doing here? I'm trying to reel you in. So it's here. We got 2 squares here. If I start that process over, we got 1 square. Where else do we got 1 square? Here and here. Okay, that's cool. If we move over 1, we got 1 square. We have got 1 square here. Okay. Okay, so we don't count these 2. We only count this 1. If I move down again, I got 2 squares. I got 2 squares here and here. Okay, I see what I'm putting down, right? You see it too? We go down here. We still got 2 squares. This is 3. Doesn't work. We got these 2. Okay, so what is the pattern here? The pattern is that we are always looking at how many squares we have to our left and to our top. And we also know that we are taking the minimum left top, and that gives us 2. Okay, so that is the 2 squares we're attacking here. Let's move it to a new spot entirely, like right here. Okay, let's do that same query again. We got 3, and that's right, 1, 2, 3. Why is that right? Because we can only attack 3 squares to our top. Because if we think about how this works, all we're doing is stepping, right? We step in every direction, -1, -1, x and y, or x this way, y this way. Okay, so if we're stepping in these directions, -1, -1, we're bound by how far we can actually travel in these 2 directions. There we go. We solved this whole problem right then and there. We know how to count this direction. Now, what if we flip it around? Let's go this way. Well, it's the same thing. We're going to take the minimum of our top and our right. We got 2. We got 2 here. We got 2 here. We move down over here. We do that same thing again. Now we got 3. How we got 3? We got 3 here. So we got 3 here. Boom. Okay, wash our hands. Oh, and the other thing is these variables, just like I had top and left, I've got top right and top left. And you can see we got 2 here, and we got 3 here. Boom. Okay, this is coming together. So I bet it holds true that we can count how far to the bottom right we can count. You think so? Let's just see. We got minimum of right and bottom. We got 3 here. Boom. Got 3. Okay, I bet my minimum for my left bottom. You know what, that sounds bad on camera. Hopefully YouTube doesn't think I'm saying something I'm not saying. We got 2 left bottoms. That's not right either, but 2, you know what, I took that way too far, way too fast. Okay, we've got a minimum on our bottom left, 2. Man, now I can't stop thinking what I shouldn't even be thinking. Okay, we're going to get back on track here. What we know how to do now is count how many we attack on our orthogonal directions, and we know how to count how many we are attacking on our diagonal directions as well. So let's do this. We got top plus right plus bottom plus left. That's our compass. We got 2 here, 2 here, 2 here, 3, 3, there's 5. 5, 10, you know what I'm saying? We got 10. Okay, we're going to count these directions now. So we got top left plus top right plus bottom right plus bottom left. We got 9. Well, let's count this. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there's our 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's our 9. If we put it together, we got 19. Now, the 19 is also available in a variable called attacked squares. And we can see the attacked squares is 19. So we did math right because the software that has no bugs, I guarantee it, the software told us it's 19. Okay, so we're moving really fast at this point. We know how to count on an empty board how many squares we're attacking. So how do we do the same thing when we introduce a pawn? Okay, let's do this again. Last time we started with top, we'll start with top again. So we got 4 squares to the top. We drag a pawn right here. Now we only have 2. Well, how do we figure that out? Well, let's think about our first constraint. To attack a pawn above us, we have to be on the same x-axis. Okay, so we got queen.x equals pawn.x. That's true. Okay, so we've proven now we are on the same axis. What's also true? Well, the pawn has to be above the queen. Well, let's do that. Let's say pawn.y is less than queen.y, and that's true. So that tells us we are not attacking down. We are only attacking up. Okay? Good. And you know the y here is not less than equals to. Otherwise, we're on the same square, and that's against the rules. Can't do that. Okay, so we know pawn is above the queen. Now, how do we figure out how far it is? Well, let's just do some math. We'll say queen.y is minus pawn.y. We got 3. Okay, so let's take away. We know now we are 3 squares away from the queen. That's pretty good. Now, the problem is we're counting the square that the pawn is on. You see how it rhymed right there? That's like I'm going to be the next poet of our century. Yeah, the pawn is on 3 squares above the queen. So if we take that number and we subtract 1, we're left with 2 squares. That is how many squares above the queen we are attacking. We count our top again. We've got 2. Okay, this is coming together pretty easy. Let's do it on the left side now. How do we count this one? Well, The first rule is that we must be on the same y-axis. So we'll say pawn.y is equal to queen.y, and we get true. Okay, so we know we're here. We also want to make sure that our pawn.x is less than our queen.x. That's also true. So we are no longer including the square the queen is on. We have to go to the left. And we already know basically how to do this. We say queen.x minus pawn.x is 4. There's our 4 squares. We do that again. We take away 1 because we don't want to count the square that the pawn is on. And we got 3. Boom. We've got 3 squares that we're attacking to our left. Boom. Okay. Cool. Beans, man. This is coming together. So let's do the same thing again. I'm going to refresh the page to get rid of the pawn. I'm going to put it where we're only looking at the right. Let's drag a pawn, put it right here. How do we know that we're attacking 2 to the right? Well, we know the first rule that we need to have our queen y is equal to our pawn y. That's true, okay? And we also want to make sure that our pawn's y is greater than, our pawn's x is greater than our queen x, and that's true. So that tells us that we're going this way, and what we're going to do is we're going to take the higher number from the smaller number. So we'll say pawn x minus queen x gives us 3, so we know this 3. We do the same thing, take 1 away. What do you get? 2. So boom. Okay, I shouldn't clap. I might have to mute that out. But we got 2, right? Because it's arithmetic. I don't know. We got 2 here, and what we're going to do next, I'm not even going to do the bottom one. You know what? I'm going to put a pawn right here. I'm going to look at it. Boom, we got 3. Let's double check. Bottom is 3. Right is 2. Top is 1. Left is 1. Left is 1. Okay. So this system is working. I'm going to let you figure that out. To give you a hint, we're doing, queen x is the same as pawn x. Pawn y is greater than queen y. Take the 2, 1 away from the other. You know what I'm saying? We get 3. Boom. Okay. Now the fun part begins. And really, probably why you're here. How do I put the queen here? Focus on the top left diagonal. How do I know how far to attack this pawn? Because if I move here, I go all the way to the end of the board. But if I move down 1, now I only attack to the pawn. How do we figure that out? Well, I'm glad you came here. Let me show you. Okay, let's think about some rules here. The first thing we want to make sure is that the pawn is to the left top of our queen, right? Right? We want to say this. We want to say pawn.x is less than queen.x. True. Okay, so that tells us that we are least to the left of our queen. We want to do the same thing. We want pawn.y to be less than our queen.y. True. Okay, so we now know that our pawn is somewhere inside of these boundaries. So the next thing to figure out is where is it in these boundaries. So let's focus in on our left side here. So if we say our queen.x minus pawn.x, we get 3. So that tells us that we can only go 3 squares to the left of our queen. We can do the same thing here. We can say I want queen y minus pawn y. We get 3 here. Oh, there's symmetry. Look at this. We are 3 above the queen and 3 to the left of the queen. So that means if we look at it, we're kind of creating a square here. Now, we need to focus on that because if this is telling us that we are creating a smaller square than we originally had when the whole board was together. And this also holds true if I move down 1 and I grab a pawn and I place it here. Now, I have pawn 1 and pawn 2.x, pawn 2.y. That is 2, 3. That's this one right here. Okay? So let's just do this again. We've got queen x minus pawn 2.x, that's 3. Okay, so we got the 3 here to the left. And we've got queen y minus pawn 2.y is 3 still. Okay, notice we're still building a 3 by 3 square. That's this 3 by 3 here. Okay, So it doesn't matter even if this one's 4 and this one's 5. It always holds true that we are counting based on these 3 like so. And we want to make sure that's true. So we can say, is my queen y minus pawn y equal to queen x minus pawn x, and that is true. So that means these are both equal to 3. That means we're building a mini tiny square right here. So now, here's where it gets fun. We already calculated, we kind of already saw this. Let me clear this out. We already know that we can say queen x minus pawn x. Remember, this is this pawn here. I shouldn't have done this, but I did, and it's too late. We know that the pawn is 3 squares to the left. Well, we can take that and we take away 1. Now we know how many squares we're attacking, and it is sure enough 2. Okay, let's do this again. Let me refresh. Let's get all this set up again, and we're going to move and put our pawn up here to the top right. Okay, let's do this again. We are doing the top right now, so we still want our pawn y to be less than our queen y. That's true. Okay, so we know we're above. We're somewhere up here above this line, and we want to make sure that our pawn x is greater than our queen x. That's also true. So that means we are to the right over here somewhere. And so we can say my pawn or my queen y minus my pawn y is 3, so we get the 3 here. Cool. And we say pawn x minus queen x is also 3, so there's our 3 this way, and we already know we just need to compare queen x is pawn x minus queen x is equal to pawn queen y minus pawn y. Boom. Okay, so we've done the same thing here. We know that it's 3 and 3, and so now we just take our pawn x minus our queen x minus 1, and we got 2 squares here. Okay? Okay, this is not so bad. So I'm going to go ahead and wrap up and not keep playing with this little demo, but what we could do if we so chose is grab a pawn and place it here, and we can see it's 2, and the same thing applies here. We're saying, is my pawn to the right and below our queen, which is saying that our pawn y is greater than queen y. That's true. Is our pawn x greater than our queen x? That's also true. Is my pawn x minus queen x equal to pawn y minus queen y? That's true. So now we say pawn x minus queen x minus 1, and it's 2. Okay. Okay, so we've got this figured out. Now let's actually solve this on HackerRank, because you know that's why you're here. You want to see me actually fumble around with the code editor thing that I'm not very familiar with. So yeah, here it goes. I'm going to do this in JavaScript. Why? Because JavaScript is the best. Now, as you can see, I have already renamed some of these variables. I am not a fan of HackerRank giving you the dumbest variable names ever to exist, because I think that's like R_C or something like that. I don't know. There's an outline of what they are in here. Yeah, like RQ, CQ. What? Okay, so we change them. Baylor changes them to make sense to us. Okay, so we got the board size. We got the queen X, queen Y. Okay, boom. So let's do this. We know right away. We want to count how far can we attack to the top. Well, that is equal to queen Y minus 1. We've already looked at that before. We got our left. That is equal to queen X minus 1. To the right, so let our right equal queen board size minus queen X minus 1. And let our bottom equal board size minus queen Y minus 1. Boom. Okay, so that gives us the top, left, the right, the bottom, and what we'll do here is just say return top plus right plus bottom plus left. Okay, I know I'm kind of getting these variables in weird different orders and everything, but my brain is coming from the margin shorthand in CSS. If you've never seen that before, it doesn't really matter. It just is going top, right, bottom, left, counterclockwise. Not counterclockwise, clockwise. Okay, so we've calculated this much. Boom. So what we want to do now is we want to iterate over these obstacles. So these come to us as an array. In JavaScript, we can say, ooh, the syntax highlighting indentation is just as bad as real Vim. And so here we go. We say obstacles.forEach. And now this gives us a tuple. A tuple is a pair of two. It doesn't have to always be that way, but it is in this case. And we can destructure that. Something. JavaScript's got this thing we can say, I gotta double check. Is it XY? Row and column. YX. Yeah, YX. So we got Y and X. Okay. So the reason I'm doing it this way is you know what? I'm gonna rename this. Oh my goodness. Yeah, this is not as good as my real, man. We got, what do we say? Pawn Y and pawn X. Okay. So I'm destructuring that so that I don't have to reference them. Another way to do that would be to say that I want pawn Y. We don't have to worry about that. We're focusing in on the real important part here and not trying to be confusing, probably any more than I'm already being confusing. Okay, so how do we do this? Well, we're going to iterate over the cases that we know. So how do we calculate is above the queen? Well, we know this. We say, or like, is right above the queen. That's horrible. Okay, we're going to say this. If our pawn X is equal to our queen X and our pawn Y is less than our queen Y, then we know we are straight up, straight above the queen. And so here we're going to change that top variable. We're going to say top is equal to, now here's the tricky part that I haven't really explained. Let's look at this. We put the queen down here. We look straight above us. We put a pawn here. Okay, it's 3. We put another pawn here, and now it's only 1. This means that we don't know the order. We don't know if this pawn comes in first and this pawn comes in second. So what that means is we always want to take the smallest number, right? So we're going to include that. We're going to say math.min, and we're going to take the top that we've already got, and then we're going to say our queen Y minus our pawn Y minus 1. Okay? Simple enough. That is for changing how far above we are the queen. Let's do this again to the left. Or no, to the right. To the right, because we've already calculated right here. Top right, bottom left. You know what I'm saying? Okay. So we're going to come in here and we're going to say if the pawn, what is it, to the right? Pawn Y is equal to our queen Y and our pawn X is greater than our queen X, then we do the same thing. We say right is equal to math.min to the right, and we're going to say pawn Y, pawn X minus queen X minus 1. Don't you love how I say the wrong variable name? It makes it really confusing. Basically, all we're doing, this is like the tricky part, or not the tricky part. This is like the non-tricky important part to actually recognize. The variables that we subtract, the variables we subtract right here are the variables that we use to define our less than or greater than. So if we say it's less than on the pawn Y, queen Y, then we take the greater number and we subtract the smaller number. So we say queen Y minus pawn Y. We say pawn X is greater than queen X, then we say pawn X minus queen X. Okay? Got me? I think you do. I'm hoping I'm making sense. So let's do the bottom case, and I'm going to rename this, or add a comment. Top, right, bottom. Okay, so how do we do this? Well, we say our pawn X is equal to our queen X, and our pawn Y is greater than our queen Y. And we got extra syntax coming in on board. Okay, we got to get rid of it. And we say bottom is equal to math.min. We take our existing bottom, and then we say pawn Y minus queen Y minus 1. Okay, and we do the same thing to the left. We say left. If our pawn Y is equal to our queen Y, and our pawn X is less than our queen X, then we say left is equal to math.min left, queen x minus pawn x minus 1. Boom. Okay, so we have now calculated the 4 orthogonal directions, top, right, bottom, left. So now we need to include our diagonals. So we know this one. This one's the easy one. We're going to have our top left. That is the math.min of top and left. Let our top right equal math.min top right. Let our top bottom right equal math.min bottom and right. And let our bottom left equal math.min of bottom and left. Boom. We got these 4 coming down. We're going to go and drop them into the addition part of it. So we're going to say top right plus top left. I kind of get that backwards, doesn't really matter. Plus bottom right plus, bottom right plus bottom left. And I'm just going to, yeah, this is perfect. This just looks beautiful. Okay, so we have calculated the empty board state like so. And really what we want to try is just click run. I just want to see this as like blow up in our faces. We walk away. Yeah, that doesn't look right. What's going on here? This test case 0, I have seen this before. It is this one. Example output is 9. We got 4. Why? Whoa. Dun 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 dun. So we know what is going on here. We got top is queen y minus 1. Left is queen x minus 1. Right is board size minus queen x minus 1. Bottom is board size minus queen y minus 1. Okay, I think that's right. And let's just take away the things that I'm thinking I might not have right. I still got 4. Why? What am I missing here? I am just telling you right now, it is the most fun to sit there and have it break like this while I'm trying to record. If you ever want to do something that's not fun, I guarantee you just start the recorder and you just hop in front of it. Oh man, what do you mean 4 each does not have on an empty array? Maybe what? Okay, we're just going to put obstacles back in. It should be an empty array, so let's figure this out. What am I missing? We got right is board size minus queen x minus 1.
Stars shining bright above you. Night breezes seem to
Board
whisper.
size minus queen dot x minus 1. I get, oh, I got minus 1. What am I missing here? Board size minus queen x. Baylor Ray, I already know this. You're not supposed to subtract here. Baylor Ray, do this again. And now we gotta wait. But this should fix it. Man, I sit there and add variables and subtracting stuff. So test case 0 is passing, test case 2 is passing, but now once we've got obstacles, this is not working because we are not including the top diagonals. Okay, we're at a working state. I apologize for wasting everybody's time, but here we go. We're going to do this for real this time. So let's do the top left. Okay, so we know top left. To be top left, we need to have our pawn x to be less than our queen x, and our pawn y needs to be less than our queen y, so that puts us to the top and to the left. And we also remember we have to say that our queen x minus our pawn x has to be equal to our queen y minus our pawn y. And if that is all true, then top left is equal to math.min, because we're doing the same thing we did before. We got to get the closest one. We say top left. And here we're going to say queen x minus pawn x minus 1. And just to be certain of this, I'm going to put this over here. We're going to look at it like so. And we say queen x minus pawn x minus 1, and that's 2. Okay, so we're doing good here. So let's do the same thing for our top right. So we say if our pawn x is greater than our queen x, and our pawn y is less than our queen y, and our queen, nope. Dun, dun, dun. Pawn x minus queen x is equal to queen y minus pawn y. Okay, so yeah, I will say this is not necessarily the most fun thing for me to try to type and think out loud, but you are here to correct me, because you're watching this screaming at the screen, sitting there singing, Baylor, man, you sat there and showed us one way, and now you're doing a different way. But here we go. We got our math.min for our top right. And here, this is an important thing that I actually blundered on before. You have to stick. You cannot say, like, here we know that queen y minus pawn y. You know what? That's kind of obvious. You can't say pawn x minus queen y. They have to be on the same direction, like top or left. It cannot be one and the other. Okay. The reason for that is if the pawn, let's just kind of visualize it. The pawn's right here, queen's right here. We're only two this way, and we are what? I don't know. Okay, let me. Oh, you can't do that because the queen is actually 3 from the top and 2 from the left or whatever. In this case, there are 3 on both sides. Yeah, so you got to stick on the same one. But here we go. We say that we want to take the pawn x minus queen x minus 1. There's our top right. Okay, our bottom right is going to be if our pawn x is greater than our queen x and our pawn y is greater than our queen y and our pawn x minus queen x is equal to our pawn y minus queen y. Then we know we're at the bottom right corner. We say bottom right is equal to math.min bottom right, and here we do the same thing. We say pawn x minus queen x minus 1. Boom. Okay, and we're going to do the same thing for our top left. Oh, I'm sorry, bottom left. Yeah, we don't want to do this twice. If we have our pawn x is less than our queen x and our pawn y is greater than our queen y and our pawn queen x minus our pawn x is equal to our pawn y minus our queen y. I'm sure you're sick and tired of hearing me saying x and y, queen and pawn and everything else, but it's the last one. We're going to say bottom left is equal to math.min bottom left, and we're going to grab one of them, and we're going to say queen x minus pawn x minus 1. Okay. Ugh. Let's run this again. Let's see what we get. Does it pass the test cases? The delay. I just like my heart is just frozen because I don't know if it's going to work or not. It didn't. Great. Now I got to sit there and try to debug this thing. You know what? This is not Uncle Bob's clean code friendly example. Okay, let's focus on it. We know this has failed before, so it's probably in these 4 conditionals. Top left, pawn is to the left, pawn is to the top.
Star shining bright above you. Night breezes.
I think this is going to be the saddest thing ever. I don't even know what time it is. I'm thinking I forgot to wrap this in square brackets, and so I didn't destructure it. I don't even know what pawn y was, but I didn't fix it. Okay, before I just discard all this, let me try swapping these around just so I can be 100% sure. Okay, and congratulations. That does not, oh man. So for whatever reason, my X and Y are backwards. It's probably because my board is reversed. Could that be it? Like what? This is each K, which is the obstacles, is the row, which is Y, and column, which is X, but I'm backwards. I passed all 16 cases. At this point, this is like, I don't even know. My enthusiasm is gone, but at this point, you know what? You learn how this works. Congratulations. I really am hoping that you enjoyed this video, And if you did, please hit the like button, subscribe. That means a lot to me. And I will see you next time. If you like me doing these HackerRank things, it was actually kind of fun building this little app. And so I'm kind of thinking that this might be a fun way to try to solve more HackerRank problems if there are more like this. The Queen's problem really, chess is a sport that I really enjoy. And I think you could solve a lot of programming problems with chess is the topic. So that's that. I really hope you enjoyed this video. Thanks for watching, and I will see you next time.